Welcome to the Data Future Lab channel. This is Shekhar and I am a data scientist. So today we are going to develop a machine learning model which can predict the beauty product based on the description. So here we will deal with the textual data, which is unstructured one. Okay. So let's get started. So the first step is you have to import the required libraries or the packages. So these packages we are going to import. In that, the pandas numpy is the basic one. Matplotlib seaborn is these packages are basically used for the data visualization. And then we have to import the string, then import the regex, NLTK, then stop words, porter stammers, this tokenization, uh, these packages which are required for the text data pre-processing, right? So this is the first one. Second, we have to read the data, beauty product data. So the data is lying in this particular CSV file, and yes, and we can see the first 5 rows. So you can see the data is like this. There is a brand, there is a category, then the currency, description, then the ID, name, price, price sign, price type, rating, and the tag list. So basically our uh, uh, what you have to do, so we have to predict this product type, which kind of the product is, based on the description, right? So you can see that how many rows are there. We will check 931 and 11 columns are there. You can display the list of columns by using a df.columns and the data type. So these data type is you can see already almost uh, all the columns are the categorical one except this rating and the price. Okay, but we have to only consider these columns, the product type and the description. So I am creating only the data frame with these two. So this is a description. Based on the description, you have to predict which kind of the product is this, beauty product is this, right? So it's kind of the what we can say, it's a classification model, but here it's a multi-class. So why it is multi-class? Because there are multiple classes are there. Now you can see that um, okay. So first we will rename this. So we will rename this, and after renaming, I'll show you how many products are there so that you can predict. You have to predict these products. Okay, dot value counts. Okay. Yes. Now you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 products are there. Where you can see that there are 10 categories with these counts, right? Now foundation is the one kind of the beauty product where it is kind of the skin related. Then this is lipstick, then eyeliner, mascara is there, eyeshadow, blush. So we will convert these 10 categories into a standard categories, because here you can say the eyebrow, then mascara, eyeshadow, and the eyeliner that comes under the eye makeup, right? So likewise we will standardize these categories. Okay, so before that, what we'll do, so we'll check what is the information about this case. So where you can see that there are some null values are there. Okay, first we'll check whether there is any duplicate values are there. Yes, so many duplicate values are there. So instead keeping this, we'll directly check how many duplicates are there. 58 duplicates are there in the data. Then you have to drop the duplicates. So we will drop the duplicate this 58, then our data is clean now, right? Now we'll check the missing values. Now you can see that there are 7 missing values are there in the description. So directly we will drop that because we can't fill that missing values, because it's all about the free text. We can't input that missing values here. Right, now you can see that your data is look like this, and uh, Uh, and we know that there are unique 10 unique products this, and 10 already we know that, right? Now we can say that the product and its count already we have seen. This is the value count we have taken. Okay, now we can plot the bar plot by using this. So simply by using SNS bar plot, and you have to provide these values. So you can see a nice bar plots where the foundation values are greater, then lipstick, then eyeliner, and then last one is a lip liner, right? Now you can check one sample description of this. Okay, this sample description developed for the selfie edge or buildable full coverage natural matte foundation. This is related to what um, the product which is the falling under the lipstick, right? So hmm. Now we have already checked the data type. So we will convert this into a string. We have converted data into this into a string data type, right? Now we will count the number of words in the description. So I'm writing here the function which is a get word count and return the length, that is a text dot split. We are splitting the data on the basis of the space, right? And we will get that, and finally we will count the list of the number of elements in that particular list. So we'll get the word count in each row, and we are going to apply this to our data frame. So our data frame is, we already know that data frame. So df3 dot head is there. So we will apply this for the description, and you will get we will create a one more column, that is word count, and we are applying this function. Now you can see that there is a word count you will get, right? Now we will check the total number of words in the data. Complete words is 82,456, right? 59. Okay, so I want to check the what is the average word count for each product. So I'm using here the group by product word count dot mean, and I'm doing the reset index, and I'm changing the name, the product, and the average word count. So finally, I will get the product and its average word count. Okay, for this, right? So most of the word count is for bronzer. Then no, it's eyeshadow. Then it's for bronzer. Then you can see it's for the blush. Okay, so we'll check what is the maximum description and the minimum description, product description. So you can see that so many description, or so many words are there in here. So, but we'll check the minimum words are two. Okay, fine. Now we will sort the word count, and we'll uh, uh, check the top five the descriptions, longest descriptions we can say here. Simply I have used the short values by using a value count. So you'll get this top one. Okay. Now shortest you can check, there are two words only, right? Okay. Now what happens? There are 10 categories. So it is very difficult for you to predict these 10 categories. Yes, we can predict, but here we have to standardize the categories, because you can see that the products are there, right? So here you can see there is a blush bronzer which comes under the foundation, or the contour, the eyebrow, eyeliner, eyeshadow, then mascara. This comes under the eye makeup, then nail polish, then what we can say, it's a lip liner, lipsticks, that comes under the lipstick product, right? So we will group these categories. So you can see that I'm grouping this. You can see how the grouping is done. This is, and so if it is a lipstick or lip liner, then it will return the lipstick. Okay. Then X is in the blush, bronzer or counter, then it will convert it into a counter. Eyeliner, eyeshadow, mascara, eyebrow, which comes under eye makeup. and else finally the nail polish will be x dot capitalized. Why? Because every time I'm using a capital word here. So run this function and just apply that function here. So you will get the new product column. Okay, so I'll show you here df3 dot head. Here is the new column is a product. Okay, where you can see now these are the standard categories. Now you can see that we have converted the 10 categories into 5 standard categories, right? Yes, so we can plot the graph, bar plot also for these categories. Here you can see the most is eye makeup, lipstick, foundation, counter, and nail polish. Okay, fine. So, yes, we can check the what is the value average word count for this. So this is the list, and this is in ascending descending order actually. Okay, fine. So you can visualize the bar plot, which is already we have seen the average word count for each category, each beauty product. So the character length. So character length is not important here. Okay. Now, the next very important part is what? So we have to do the text pre-processing for the model building. So initially what you have to do, so the text cleaning we have to do. So for that, we have to just remove the stop words. We have to remove these are the stop words. And we have to remove these stop words. Then what you have to do, you have to remove the um, we have to convert into a lowercase, then you have to remove the numbers from the text, then you have to remove the punctuations, and finally we have to remove the white spaces. Now everything is there. So first one we will write the function to remove the stop words, right? So here we have written the function. So w for w in the text dot split if w is not in stop word list. So these are the stop words. So you can take that stop words from the analytical library also. Then we are lowering the text here. You can see that um, here we are converting all the text into lowercase for this application, this function. Then here we are removing all the numbers which are present in the text because that should be removed by using the regex. All right. Then here we are removing all the punctuation marks because that are not important. You can see these punctuations from the string and that we have to remove. So for that we are using a string.makeTrans string punctuation, and we have to return the text.translate and translator. So where it will remove all this, right? Now we have to remove all the extra white spaces and keep only a single white space. Okay, now we have removed all this. So we have written almost 5 functions. Now we can write these 5 functions, 1, 2, 3, 4, 5, and finally we'll get the clean text. So text cleaning is I have written another function and I'm calling these all the functions above functions here. And yes, so finally you will get the text cleaning by using this, right? So this is the sample one. So our data is here. You can see our data is lying here, df3 dot head. Okay, now we have to apply this text cleaning to the description column, and I have to write the clean description. So description dot apply. I'm using a lambda function. So with lambda function, I will use the text cleaning here, and you will check. So you will get the clean description here, right? Then I'll keep only these two columns. One is the product and the description. Okay, so this is the X and this is the Y. So we have to train your model based on these descriptions, and you have to predict this product ID. So again, we know that this is the number. So I will encode the target variable. So target variable is the product. So what I am doing, so I'm creating one more column, that is the product ID. Here is equal to text df product. And I'm using the factorize and accessing the first element. So what you will get like this. 0 is lipstick, 1 is foundation, 2 is eye makeup, 3 is counter, and 4 is nail polish. Okay, fine. Now I'm converting the data into X and Y. So X is the cleaned description and Y is the dependent variable, that is the product ID, right? So uh, yes, so here we are converting data into X and Y. So this is Y, okay, this is Y, and I'll show you X. So X dot head is this, and here is Y dot head. I'll do, okay, head is this, right? Y values, right? Now, next one is very important. Now, if you want to train the model, so the machine will not understand this text, so we have to convert this text into a vector form or the numbers or the matrix. And for that, we are having a bag of words techniques where we are converting the text in data into a matrix of tokens or the numbers. And for that, we are going to use the count vectorizer or TF-IDF transformers, right? So here I'm using both. So you have to import the count vectorizer sklearn.featureExtraction.text, and again the same import the TF IDF vectorizer. The function of both transformers or these algorithms is same to convert the textual data into a matrix, right? So I'm creating the object of this TF-IDF and the count vector, but I'm using a count vectorizer only here. In this case, you can use anyone, okay, as per your choice. Now we will split the data into a training and testing. So X train, X test, Y train, Y test, train test split, X, Y, test size is 20, and random state is 0. Okay, now here you can see the shape of the train and the head of the train, right? Now you have to convert this data into a vectors, and then for that we have to apply whatever the object here we have created, that we have to apply to that xtrain. Now you can create the xtrain underscore count vector. So a count vector dot fit underscore transform xtrain. Here clean descriptions dot values. So you have to convert these into values. Sorry, in the values. Uh, Before that, you can see that like this. Initially, our data is like this, okay, but we have to convert into a kind of array, right? Array, and that array you have to feed it to the count vector. Then TF-IDF I am not using this, so you will get this, right? So we will check how it has converted into this. Now you can see that this is the object, but if you convert that into a two array, so you will get the array. Now this is the sparse matrix. So whatever the these values are converted into numbers, and that numbers you can see here like a sparse matrix. Okay, so now the conversion is takes place. All the text is converted into a vector form, right? Then we have to start the model building. So in the model building, you have to import the two models. That is the nerve-based one, and second one is the linear SVC. That is again a good model for the text classification. So here we'll do the text classification by using a nerve-based model and the linear SVC, support vector classifier. Here we are considering a multinomial nerve base, and here we are considering a linear nerve base, SVC. Okay, now we will create the object of these two models. Now we will train the model here by x train count vector and y train x train count vector and the y train. So though both models gets trained, now you have to do the predictions based on this. But before predictions, you have to convert this data, X test data into the values actually. So these are the values basically. And now you can see for the prediction, I'm using this model, naive-based model, dot predict. And here you have to transform the data because X test Values will be again a text, right? So this is the text. Now this text we have to convert into a vector form. But here you have to use only transform, not a fit underscore transform, because for the training we are using a fit underscore transform. Initially it will learn from the data, that is called fitting, and then it transform the data into a vectors. The same logic we have to apply here, but again you need not worry train the model, because model is this algorithm object is already trained. Only you just have to conduct the transformation on the x-trace values. Otherwise, what will happen? There may be a leakage of data will happen, and there will not be any uh, learning things will happen in the learning will happen in the this algorithm. So now you can see why I'm getting uh, uh, these predictions, right? Now we will check what is the matrix, evaluation matrix. So directly I will use the classification report here. So here you can see the accuracy is 91%, then precision is good one. So it is good model actually. Same we will check with for this. So its accuracy is 89%. So in this case, we can say that the naive-Bayes model is working fine here, so than the linear SVC. Then we will plot the confusion matrix for this. So in the confusion matrix, what happens? These are the correctly classified and these are the misclassified. So you can see that the 2 and 0 are misclassified mostly. Then 3 and 1 is also misclassified greatly. These two are 0 and 2 are the confusion, 1 and 3 is also confusing because they are having greater misclassifications, right? Okay, fine. So let's get started. So we'll check a single predictions here. So before that, we will check the model. Product ID is lipstick, foundation, eye makeup, counter and contour and nail polish. So initially, I will give one text here. So you can see the text. The product free lead, heavy metal, paraben, phthalate, artificial color, synthetic, fragrance, bush, lipstick. Okay, and I'm using that dot predict, count vector, and dot transform. Let us check what it predicts. So it predicts zero means it's a the description is all about the lipstick. Then again, whether your skin is oily, dry combination, there is a minimum foundation is there. So I'm using this description here and check. It's a one means it is showing a foundation. Okay, great. So the next applying material to clean moisturize skin will ensure it goes smoothly. This description tells about the one again. So it's a foundation. Then extra credit you will counter your lip, and you can see that this is all about lipstick, right? Okay, fine. Now, for the customized predictions, I'm writing here the function get model predictions, where the predictions from this particular text is 0, then it is lipstick, 1 is foundation, 2 is eye makeup, and 3 is contour, and last one is the nail polish. So I'm running this function, and simply I need to pass this text to this particular function. So this is the this innovative serum infused mascara. So mascara means it is related to eye makeup. Okay, great. So cosmetic products significantly designed for painting and decorated. Okay, this is again gives you regarding the makeup, eye makeup. Okay, likewise you can do the predictions on your own for this data, and this model is working fine. It is giving a 91% accuracy on this particular data. So this is all about the creating a machine learning model based on the textual data, where you can predict anything based on the text free form of the text. And for that, naive-Bayes model is the very good one, right? This is all from my side. If you have any questions, you can just ping me. Thank you. Thanks a lot.